This video is part of firm theory production. In it, I discuss total product, average product, and marginal product, as well as the relationships among all three measures. Importantly, this video talks about production in the short run. Recall from the definition of the short run in economics that in the short run, at least one input cannot be varied. That is, the short run is the amount of time during which at least one input is fixed. Now, we're only working with production functions, and this is only for simplicity, that are functions of two inputs, usually thought to be labor and capital. When that's true, we usually default by thinking of capital as the input that is fixed in the short run. Now, this doesn't always have to be true, but it makes more sense because the firm can add more workers, for example, by working existing workers overtime or hiring pretty quickly new temporary workers. But capital, on the other hand, might take more time to acquire. So unless otherwise noted, capital will be assumed to be the fixed input in the short run and labor the variable input. The production function in the short run is Q in terms of labor, again, it's assumed to be variable, and capital, again, assumed to be fixed. Note that output also can be known as or called total product, TP. So when I say or when you read total product, know that total product is the same thing as output, and both measure how much of a firm's good or service can be produced. Marginal product, like any other marginal, is about the incremental. Marginal product is the incremental or additional output that can be produced when the firm adds one more unit of labor holding capital constant. Marginal product's going to tell the firm if it uses one more worker how much additional output will be produced. Like every other marginal utility, marginal cost, marginal product is a derivative. It's a partial derivative of output or total product with respect to labor, and as a partial derivative, it's holding all the other inputs, here capital, constant. Average product is the output per unit of labor. Average product is calculated by taking total product or output, Q, and dividing by the number of workers. Let's see what we can learn about total product, average product, and marginal product from these pictures, which often appear in introductory and intermediate textbooks. First, note the top graph's axes. On the vertical axis, we have output, and on the horizontal, we have labor, workers per day and output per day. What we see from this top graph is that up until point C, or 20 workers, output or total product is increasing as the number of workers per day is added. That is, up until point C, using more workers means producing more output. One thing I want you to know is that when output or total product is increasing, marginal product is positive. Note that until 20 workers per day, the marginal product curve is above zero. Again, when total product is increasing, marginal product has to be positive because a positive marginal product means adding another unit of labor adds a positive amount to production. More labor, more production. Now, let's look at the rate at which the total product is increasing. What I want you to see on this graph is that initially, as the firm uses more labor, until the 10th worker at point A, total product is not only increasing, but it's increasing at an increasing rate. When total product is increasing at an increasing rate, marginal product is positive and increasing itself. Total product increasing at an increasing rate means marginal product is positive and increasing. What that says is that every additional worker is adding more to output than the previous worker. Why might that be? Well, typically the reason given is division and specialization of labor. Initially, when the firm only has one worker, that worker has to do every task needed in the production of the good. As the firm starts adding more and more workers, workers are able to divide up those tasks, and through the division of their labor, they can specialize in one or a few tasks. And we see specialization makes the productivity of workers increase. So up until the 10th worker, that's what we're seeing. Total product is increasing at an increasing rate. So marginal product is both positive and increasing, likely due to the division and specialization of labor. That doesn't persist forever, though. According to this graph, once we get to 10 workers, from point A until point C, total product still increasing, so marginal product, remember, still positive, but total product is now increasing at a decreasing rate, which means marginal product is decreasing. Notice that marginal product is the rate at which the total product is changing. So after the 10th worker and up until the 20th, adding another worker does add to output. More worker means more output, but each additional worker doesn't add as much to output as the previous worker. Why is that? Well, remember we're in the short run, so capital's fixed. We're adding an 11th, 12th, 13th, 14th on up worker. We're adding more and more workers, but we're not adding more and more capital for those workers to use. This is what causes likely the reduction in the productivity. Each additional worker doesn't add as much as the previous worker because they're starting to crowd out the capital. Finally, what we see on this graph is that after 20 workers, output actually starts to fall. Now, adding another worker causes production to decrease, so the marginal product is negative. That might happen if, for example, there's so many workers that they are literally getting into each other's way and bumping into each other, and when they do, the output that is being produced might fall on the ground and break. This slide summarizes what I talked about on the previous graphs. On the previous graphs, the total product of labor curve showed that output rises with labor up until L equals 20. Initially, that total product was increasing at an increasing rate, which meant the marginal product was increasing, which we call increasing marginal returns. Increasing marginal returns is when the marginal product of an additional worker is more than the marginal product of the previous worker and is likely due to the division and specialization of labor. However, we saw from the previous graphs that eventually total product, though still increasing, increased at a decreasing rate. This is where the marginal product decreases, a phenomenon called diminishing marginal returns or diminishing marginal product, which is when the additional output from the additional worker is less than from the previous worker. Diminishing marginal returns usually arises when workers begin to struggle to deal with the fact that one of the inputs, capital, is fixed. On the previous slide, we also saw that total product or output eventually started to fall. That was there for labor bigger than 20, which meant that the marginal product was negative. Note the relationship between marginal product and average product. Whenever the marginal product of labor is greater than the average product has to increase because the marginal is pulling it up. You already know this relationship even if you don't yet know that, because you think about marginal grades and your grade point average. you know that if the additional grade points you get in a specific class, meaning if the grade you get in a specific class is higher than your average grade, your GPA, you know that's going to pull your GPA up. That's the same thing that we're saying here. Whenever any marginal is above the average has to get pulled up. And likewise, whenever any marginal is less than the average has to get pulled down. Again, you know that if you get a grade in an additional class that's lower than your GPA, that grade's going to necessarily pull down your grade point average. Likewise, when the marginal product of labor is less than the average has to get pulled down. Now, if the average product has a maximum, or for that matter, a minimum, at the optimum, the marginal has to equal the average. And that's simply because if we're talking about the maximum of average product, at the maximum, the average is no longer going up. So if the average is no longer going up, the marginal can no longer be above it. And at the maximum, the average is not yet going down. And if the average is not going down, the marginal can't be below it. So marginal product can't be above, can't be below the average at the maximum, therefore has to be exactly equal to the average. This relationship is something that can be demonstrated mathematically, and that's what you see right here with this mathematical proof that at the maximum of average, marginal and average are the same. This is not a proof that you need to know, but is presented here for those of you for whom this would be interesting or beneficial. This relationship between marginal product and average product is demonstrated on this graph. Notice how when average product is increasing, that marginal product is above it. Further note that marginal product doesn't have to be increasing itself. Specifically, between A and B, marginal product is falling, but because marginal product is above average product is still going up. Then we see when average product is falling, marginal product is below it. Anytime the average is falling, the marginal has to be below it to be pulling it down. Lastly, let's circle back to the law of diminishing marginal returns, which says that if a firm keeps increasing an input, holding all the other inputs and technology constant, the corresponding increases in output will eventually become smaller. When production exhibits diminishing marginal returns or diminishing marginal product is falling. But remember, if marginal product is positive, even if marginal product is falling, if marginal product is positive, then total product is still increasing, but it's increasing at a decreasing rate. Now, this is something that isn't really a law in the sense that it always has to happen. It seems plausible, though, that if capital is fixed and you keep adding more and more workers and basically throwing more and more workers at a fixed stock of capital, it makes sense that eventually the marginal product of each additional worker is going to fall. But what you're going to see mathematically with the production functions we're using is that for some of those production functions, there is never decreasing marginal returns, whereas for others, there might always be decreasing marginal returns. So this law of diminishing marginal returns is something that you're going to check mathematically by looking at the sign of the derivative of marginal product of labor with respect to labor. Specifically, if the derivative of marginal product with respect to labor is negative, then we say labor exhibits diminishing marginal returns, or the law of diminishing marginal returns holds.